back class. Welcome back to our lesson. So this lecture video will be in continuation gihapon sa topic other special techniques on calculating the electric potential. So we'll be considering this lecture video on uh, another technique na pod on how to calculate the electric potential given a charge distribution. Okay, so today we'll focus our attention on this one. Um, on multipole expansion. So we have a multiple expansion. Ako lang nang i-convert to. Okay, so what is this multiple expansion um, all about? So for example, given, let's say we have a charge distribution. Okay, so how will your charge distribution look like if it is viewed from very far distance? Okay, we've actually encountered this question already in uh, previous chapters in previous semesters ato ang discussion on calculating the electric field and potential. So how kama na siya na this is so how will the potential look like from a far distance? Okay, so automatically when you have a charge distribution and if it is viewed from a very far distance, it will most probably or definitely look like a point charge, di ba? So layo na kay ka, mura siya mo, mo, mo gamay na ba ang imong eh, assumingly point na source charge. If you look into zoom in mo siya, it's actually a charge distribution. Okay, so from a far distance your potential would approximately look like this. So approximately it is given by this formula. So that's a very familiar formula for a potential because actually that is the uh, this is the potential, diba, of a point charge, right? However, for this case, so this is for any given charge distribution, so the na siya total Q. So that total Q represents the total charge of that charge distribution. Okay? R is katong distance. Okay? From the source to the, let's say, field point. Okay. So definitely any charge distribution, if viewed from a very far distance or far away, very, very far away, so it would look like this. Uh, Somehow it's just a point charge distribution. But we would like to look into a far more detail than that. Okay, dapat mas detailed pa ani. Okay, it could be nga this is just a one form wherein ma-view siya from a very far distance. But how about if napay mas specifics pa ana ba? Let's say because approximation man ni siya. So is this exact or how how close is this to the true value? So that's what we want to find out in this lecture video. Okay, so for our example, let's consider this. Okay, so this is our example. So let's consider, for example, a dipole. So you know what a dipole is? It contains negative charge and positive charge separated by a distance, let's say d. So tara, okay, separated by a distance d. And then the question now is how does its potential falls off as one views it from a very far distance? Tara. So let's say at point P, sa kahaiyahang, so at point P, how will the potential look like? Okay? So, at saka ang iyang pag fall off sa imong potential, ma-fall off because as you go far away from the source, say your P extends up to very, very far distance, your potential would approximately equal to saman. Unsa kapaspas siya mo gamay, right? So, sa siya kapaspas mo fall off ang iyang value. Is it the same siya nga behavior if it's a point charge, not a dipole? So, kasi mas paspas mo fall off or mo paspas mo gamay iyang value sa potential. Is it the dipole or the one charge only? We'll try to find out in this video. So for this case, we can solve for the potential sa kading system. Okay, the potential for that is given by, di ba, mamo na formula na to. Qi over 4 pi epsilon naught Ri. Right? Oh, let's try to na lang. 4 pi epsilon naught Ri. Okay? So Ri is from the, let's say from this one, from this source positive Q to P, so that would be R plus, and then for the negative Q nga source charge, the distance is from the negative source charge Q up to point P, and it's given by R minus. So if we expand this one, so we have 1 over 4 pi epsilon naught. So that's positive Q for the first case, for the first charge, and that's R plus and distance. Minus Q kay negative charge, negative ang iyang charge, and R minus. Okay? So we could further simplify this one if we use, di ba, this is this triangle, kani Q at Q padulong sa center, and this. Okay? So kana siya nga triangle, right? We can use a cosine law. Kani pod nga triangle sa ubos. Okay? We can use the cosine law to get a relationship between R plus and R minus. Okay, so recall cosine law. So your cosine law would actually look like this. Nakoy triangle. Tapos we have angle alpha and beta between that legs. And then gamma. This is of length A, length B, and then length C. So given this triangle, the relationship between these angles and sides is given by this formula. C squared equals, actually na-derive nato na siya last time, di ba, sa previous na to na previous sem, sa itong previous na course on electromagnetism 1. A squared plus B squared minus 2AB cosine gamma. Okay, that's it. So we can use this formula in order for us to solve kaning R plus and R minus. Okay, kaning R plus and R minus. Ako na nang i-close B. So we have, let's put it this way. So we have, so for R plus, using the law of cosine, so where, call this, where A is your D over 2, right? And then your B is R plus. Okay? Ang C nimo is the the R. Okay? So we can actually do this. R plus is just R square. So ang R plus ang yung pangitaon. Okay? So ang legs nga to ang side nga to gamiton is kaning D over 2 and kaning R. Okay? So R square plus D over 2 square. Then the angle between them is just cosine theta. Okay? You have RD cosine theta. Okay, so mag-cancel naman na may 2 mo na siya diha. Tapos this is D over 2. Okay? So for this is square. So for the R minus square, we have the same formula, the law of cosine. Okay, minus RD. Oh, it's not cosine theta anymore. Kaya lahi naman yung angle, right? This is theta. Okay, balik ta. So this is theta, angle theta sa picture. So we want this angle para sa R minus, so that's actually 180 minus theta. Okay? So for R minus, said na cosine theta, that would be cosine 180 minus theta. Okay? So to evaluate the R minus, kin naman ay 1 cosine 180 minus ano man na siya. Okay? So we'll recall the formula on cosine A minus B. That's actually cos A cos B plus sine A sine B. So we'll apply that to our cosine 180 minus theta. So ang R squared minus becomes R squared plus D over 2 squared minus RD. We have cosine 180 cosine theta minus plus sine 180 sine theta. Okay? So notice na kaning sine 180 is just 0. And then cosine 180 is negative 1. So we'll have R squared plus D over 2 squared minus this is plus na kay negative 180 man na, negative 1 man ang imong cosine 180. So this is plus RD cosine theta. So naa siya similarity right sa R plus ug R minus. So take a look at the R plus. So this R plus and this is R minus. So nag-differ lang siya sa sign sa RD cosine theta. So we can simplify that all together. So we have squared plus minus. So that's actually R squared plus D over 2 squared. So for plus, ma-minus na siya. Kung R minus, ma-plus na siya din. That would be RD cosine theta. Okay? And we can factor out the R square sa kanina expression. So we want to factor out R square kaya later on magamit nato siya natay condition ba nga ang R is very very far na siya. Okay, it would be much greater than D, so we can make some approximation later. Okay, so igawas na itong R square, that would be 1. Tapos, nahon lang na ako na siya. That would be d over r cosine theta, and then plus d squared over 4r squared. So I hope nakapalo ra mo. Then we can safely eliminate this because this is just too small, because later on, because d actually is much greater than r. Okay, we are talking about large na distance, palayo na kayo siya. D is the distance between two charges, right? Pakita din. Tara. So we will assume nga layo na kayo siya. So this will approximate to 0. We can safely uh, eliminate that or neglect. Okay. So next, so uh, say knowing that D is much less than R, we have R plus minus itong kaning siya. So from here, right, you take the square root, so you get actually R 1 minus plus D over R cosine theta. Okay, kaya na lang. Okay, wala naman tong third term. To the 1/2, okay, square root. So we have now this expression for R plus minus. So we can actually substitute it here. So further, we can simplify to if we have 1 over R plus. So if we do this, tsaka hay form ana R plus minus. So ibali naman siya, right? Reciprocate. Then we have 1 minus plus d over r cosine theta, then negative 1/2. Okay? So since d is much lesser than r, so we can do a binomial expansion, okay, for this term. Okay? So use better siguro sa taas na lang. Okay. So use binomial expansion theorem. We have this formula for that. 1 plus x to the n equals 1 plus nx plus, so you can look it up sa inyong any mathematics book. You can just search it on Google regarding binomial expansion na theorem. Okay? And so on. Okay. So applying that to this one. So applying that, we have, so this term 1 minus plus d over r cosine theta to the negative 1/2. So this is 1 and this is your x and this is your n to the power. So we have this formula, we can use that. So this is actually 1 minus plus then negative 1/2. So can we follow lang sa solution? Okay. Say up to 2 terms lang. Okay. This is let's say divisible na siya because as I've said, d is much lesser than r. So we have this 1 plus minus d over 2r cosine theta. Okay. So this one, substituting it here, right? So 1 over r plus minus becomes 1 over r times this. Okay, so 1 plus minus d over 2r cosine theta. Okay. I hope naka-follow ra. And then we can do this one. Kaning, kaning sa picture. Kaning siya. 1 over r plus minus 1 over r minus. Okay. So we can do that. So 1 over r plus minus 1 over r minus equals, that would be 1 over r, 1 plus d over r cosine theta minus 1 over r, 1 minus, and this is over 2r, okay, 2r cosine theta. So what do we do here? We just have to simplify. So we have 1 over r, i-distribute nimo, plus d over 2r squared cosine theta minus 1 over r plus d over 2r squared cosine theta. So we'll cancel mo na siya, right? So we are left with d over 2r squared, times 2 naman si ano. So mawala na ng over 2. So that becomes d over r squared cosine theta. So we have this 1 over r plus minus 1 over r minus. So i-substitute nato siya here sa kani ato ang potential, right? So let's write it again, our potential. So our potential, we have 1 over 4 pi. So for dipole ni siya nga potential ha. So that's Q, 1 over r plus minus 1 over r minus. That would be, so approximate na ni siya, right? Okay. We did sa approximation here because we are considering that r is much greater than d, or d is much lesser than r. So we have q over 4 pi epsilon naught d cosine theta over r squared. Okay, so take a look at the formula for the dipole na saya. So is it the same sa potential sa one point or the monopole, so to speak? Actually, lahi, right? Because for the monopole, diba ang monopole kay over 4 pi epsilon naught r, okay? So mas dali ma-fall off. Dali mo gamay ang value sa imuhang r square, okay? So if we continue this one to say quadruple is upat ka buok. So mas mogamay pag ang iyahang mas dali siya, mas mupaspas pag og gamay ang value or mo fall off compared sa dipole. How much more kung octopole, okay? So let me insert an image. Tada. We have, okay, so take a look at this. We calculated the, right? So this is the monopole. Itong 1 point lang, so we have this. Okay, we have this. And for the dipole, the one that we just calculated recently, kani, tara. So take a look at this 1 over r squared here. And the exact form is kani, right? And then if we go on and calculate the quadruple, you will notice na ang iyang v is r cubed. So mas dali, the farther you are away from the source, mas dako ang iyang pag-decrease sa potential compared to dipole, compared to monopole. Okay? How much more sa octopole, mas dali mo gamay, ma-fall off ang iyang value. Okay? So let's consider another example wherein instead of a dipole, let's say we'll try to generalize it into a charge distribution. Okay, so let me insert an image. Let's say we have this charge distribution. Okay, so given the charge distribution, we can propose to develop a systematic expansion for the potential. Okay, on an arbitrary, this is localized distribution in terms of powers of 1 over r. Okay, we'll try to get a baga series or summation of contribution of monopoles, dipoles, and so on. Okay, power of r man siya. Tara. Power of r, 1 over r, 1 over r squared, 1 r cubed. 1. So we'll try to generalize or generate an equation in finding the electric potential of a charge distribution as a function of this. 1 over r, 1 over r squared, 1 over r cubed, and so on. Okay. So the potential for that is given by this. Okay. Ang pagkuha sa potential, since volume man na siya, volumatic, so it's volume. So we have 1 over r. Okay, kaning r. R is a distance from the kanang script tr, distance from the source charge up to the field point. Okay, so this is 1 over r prime, d tau prime. Okay. So again, the same thing that we got kanina sa dipole, we will get an equivalent expression for this r given this figure. Okay, right? So we can do that by using the law of cosine. Okay? So you using the law of cosine here sa imuhang figure, so it's easy for you to see that. So we have volume, problematic mo na akong mouse. Okay, later on na lang. Okay, so this is d tau. So this is okay, sorry about that. So this is d tau prime. So using law of cosines, so from the figure, tanaw na to, we are interested in finding the equivalent expression for r squared, kaning r. So that's actually r squared plus r prime squared minus 2r r prime cosine theta prime. Okay. So again, the same process. We take out the r squared from the equation. So common niya is r squared. So we have r squared. So we are interested to look in atong mo nang gi-factor out atong r squared because makabuhat man tag approximation ana as we will impose nga ang kaniscript tr or the r itself is much greater than r prime. Okay, so we have 1 plus we have r prime over r squared minus 2 in r prime over r over cosine theta prime. I hope nakafollow na. Okay, using the law of cosine. Okay, so we can simplify this. So we have r squared 1 plus kanina po no part is factor out na po mo ang r prime over r. So r prime over r factor out we get r prime over r minus 2 cosine theta prime. Okay, have that. So we can write this as, so why are we doing this? Because later on, makagamit ang binomial expansion. So it's like a trick na i-manipulate mo equation, imo siyang baga i-massage mo siya ba nga. Wala kay gibuhat nga daotan. Just you transform it into a form nga mas familiar siya and sa yun isolve. So this is r squared times 1 plus si epsilon. Okay? Where epsilon is a very small value. Epsilon is just, saan yung epsilon? Saan siya? R prime over r minus 2 cosine theta prime. Alright. So that would be your epsilon. So your r square becomes, so r square, if you take the square root, r na lang, it becomes r square root of 1 plus epsilon. Okay. So this is very small. Okay. That's very small outside the charge distribution. And we can take the binomial expansion because of that. Okay. So the same gihapon ang atong formula of the binomial expansion. So we will take the reciprocal of this because moment ang sa potential. This becomes 1 over r, then 1 plus epsilon to the negative 1/2. Again, recall your binomial expansion. You have 1 plus x to the n. Okay, so we have 1 plus nx plus n up to third term. Okay. Okay. So using that binomial expansion, we can have 1 over r. Okay. So use this formula. Okay. So that would be 1 minus 1/2 epsilon plus 3 over 8 epsilon square. So this is 3 over 8 epsilon square minus 5 over 16 epsilon cube plus and so on. So diri yun nagikan ha sa katong binomial expansion nga formula. So where x is epsilon, n is kaning negative 1/2. Okay, from this we can simplify it further by, so ato i-substitute ang value sa epsilon para makita nato. That would be, okay, use a bracket. 1 minus 1/2 epsilon is just r prime over r times r prime over r minus 2 cosine theta prime plus 3 over 8 r prime over r. I hope nakafollow ra mo. R squared na siya. So r prime over r minus 2 cosine theta prime square minus 5 over 16 r prime over r cube. Okay. R prime over r minus 2 cosine theta prime cube plus and so on. Okay. Medyo taas, but sign naman siya. So I hope ma-follow na siya. Next is, we'll expand what's inside. So square man ni siya, kaniding second term, is i-expand na to siya, i-distribute, right? At ipod kaning cube. R prime over R minus 2 cosine theta prime cube. I-expand na to na siya. So, we'll be using the formula sa kaning pag-expand sa cube. A minus B cube equals A cube minus B cube minus 3AB A minus B. Okay? Where A here is what R of R prime over R. B is B is 2 cosine theta prime. Okay? Let's simplify it further. So we have 1 minus 1 half. So i-distribute niya siya. That would be R prime over R square plus R prime over R cosine theta prime. Then the kani siya nga term na yun, i-expand, i-distribute nimo plus 3 over 8 R prime over R cube. Okay? Naka-follow na ba? I hope na ma-follow na siya. And then minus so kani siya i-expand mo na siya ha. So ang kani sa to nga squared man na siya. That would be R prime squared minus times 2 R prime over R times 2 and so on. Okay? So diretso na ko ha. This is 3 half R prime over R to the 4. Ah, sayop. So na ni. So ang first term is it should actually give you this is square tapos kani square to the 4th. Okay. That would be 3 over 8 R prime over R to the 4th minus 3 half R prime over R cube cosine theta prime plus 3 half R prime over R squared cosine theta prime. And then the last one is katong cube. So okay, let's say mo stop na ta sa 4th power. So or stop ta sa as a 3rd power na lang. Okay? So this is sa first term atong kwaon. So this becomes plus okay, mo stop ta sa 3rd power I mean. So we can actually get the third power if ang i-multiply nimo ani is katong kaning kani siya sa 2 cosine theta. Kay wala man siya R prime over R. So R prime over R din nga coefficient is cube naman na siya daan. The rest kay mo more than na siya og third power. Summation, this is summation, this is series, so extend pa siya sa tanan, okay? So kanin dili lang sa tataman kaning sa third order nga R prime over R sa for the cube nga part, okay? So we can simplify this one. Makakuha tag nindot nga pattern. So we have 1 over R. So itong buhaton is ipang-usa na to ang tanan nga R prime over R. Okay? So, asa man ang na r prime over r din he. So, this one, r prime over r. The rest kay squared naman na siya. So, unahon nato na. That would be 1 plus r prime over r cosine theta prime. Next is usahon na to ang tanan nga na ay r prime over r square. So, asa man na siya. Kani, this one, and this one. Okay? So, factor out r prime over r squared. So, that would give us 3 cosine squared theta prime. So, nano siya squared diri guys. Squared. Paman. Yeah, na siya squared dapat diri. Pag kato ng pag-expand na to sa kato nga, ano siya, this is 2, na siya squared diha. Okay? So, this is 3 cosine squared minus 1 and then over 2. Okay? Namo siya over 2 nga factor. Plus, usawa na po din mo tanan r prime over r cube. So, asa man na. Okay, so we have this and this. So, kani siya, napo na siya partner kaning to the fourth. If imo siya extend dito imong kuan, i-complete nimo siya og solve ba. But anyway, for the purpose sa ato ang calculation, even up to third order, third power, makakuha na tag pattern. Nindot. So, we have r prime over r cube. So, ang common nila is kana, tapos factor out mo, we have this coefficient, cosine cube theta prime minus 3 cosine theta prime over 2. Okay? So, actually, this is already remarkable na natay pattern nga makuha because if keen ang imong eyes kasi naka-memorize pa yun mo, fresh pa kayo sa inyo, actually fresh pa ni sa inyong mind, nga maka-familiarize yun mo ani nga mga form. You have cosine theta, kani nga form, 3 cosine square theta prime minus 1, and 5 cosine cube theta minus 3 cosine theta. So, unsa man na siya nga mga form. So, that's actually, so ang mga coefficients, di ay niya, then extend pa na siya up to 4th, 5th, and so on. If imo siya i-continue ang summation, ay imong series. So, the coefficients are actually what? Legendre polynomial. Right? So, Legendre polynomials ang imong pag-solve. Nag-solve naman ta og potential diba sa charge distribution. And we found out nga ang ihang 1 over r, right? This is still 1 over r is ayang coefficient is a Legendre polynomial. Remarkable, isn't it? Remarkable. Right? Remarkable. So we can simplify that 1 over r as 1 over r summation. Okay, series man na siya. N equals 0 up to infinity. Then we have r prime over r to the n, and then that's Pn. Okay. So if you are not convinced kung Legendre polynomial ba yun na, let's try to Google it. Right? Itong tanawon. Okay, the Legendre polynomial. Tara. Saan naman eh? Not symbol. Polynomials. Tara. Tara. So we have 1, x is cosine. So cosine 3 cosine squared minus 1 over 2, di ba? 3 cosine squared over 2. Tansunod kay 5 cosine cube minus 3 cosine theta. Tara, 5 cosine cube minus 3 cosine, and so on. Okay? So that's actually amazing. Nasa lang nakuha nga pattern ba? Okay? That the coefficients is actually ni-resemble yun siya sa Legendre polynomial. So we can uh, insert this 1 over r sa ato ang potential. So the potential now in terms of the Legendre polynomial gives this one, the 1 over 4 pi epsilon naught okay, so I have 1 over r to the n plus 1. So, pwede ta malibo ato i-recall recall data. Ang v na to is kani ang formula, right? Okay? So, kana siya. So, i-substitute na nato ang value sa kaning, kaning 1 over r. So, giusa na to ang kaning, that's why we have 1 over r to the n plus 1. So, mausa naman nimo ang r to the n of 1 over r. Okay. So, that would be the integral of r to the r prime to the n. And you have Pn of cosine theta prime rho r prime theta prime. Okay? So this is actually exact. The solution is exact, but for approximation purposes. So exact siya if you take into consideration ang tanan nga summation from n equals 0 up to infinity. But if for approximation lang, say up to n equals 3 lang or n equals 4, then actually that will give you enough guarantee nga ang imong solution is close to the exact. Okay? So, we'll find out later as we ato na siyang i-explicit. Okay? Explicitly, meaning atong i-take ang sum. So, V of R is actually this. So, 1 over R. So, for n equals 0, so substitute nimo ang n equals 0, that will be 1 over R. Then, the integral R prime theta prime plus n equals 1 na po. That would be 1 over R squared na R to the 1, okay, or just R prime cosine theta prime, then your charge distribution theta prime plus for n equals 2, that would be 1 over R cubed, okay, then the integral R prime cube, then this coefficient, then and so on, okay, summation. So you will notice here na if you want to calculate the potential of a charge distribution and viewed from a very far distance, so we can actually do an approximation by using this equation. Using this equation. Where in fact, you will notice Nga kaning first term, that's 1 over r. That's actually monopole. Okay, katong one charge. Then the second term, 1 over r square man na siya. That's actually the dipole potential. Right? And then for the r cube, that's for your um, quadrupole, octupole, and so on. Okay? So this equation will actually provide you a um, the lowest non-zero the potential of the lowest non-zero term for a very large R. Okay, so this will actually give you a very good result already if you retain the first term only. Okay, that's for monopole. If you want to get the charge distribution viewed from a very far distance, so it's very safe to say po nga ang potential niya is given by the first term only. So wala na ning dipole and quadrupole. But if you want to if you want to improve your approximations, then or improve yung approximation for greater precision if required siya, then you can include the second term, the third term, and so on. Okay, for dipole and quadrupole, some kind of a correction. Okay, not only the monopole nga term. If you include the dipole, quadrupole, and if you include everything, then your solution will be exact. Okay, so it will not be an approximation anymore. Okay. So that's all for this vid lang sa, and then this is part 1 for the monopole, multipole expansion. Then the next video will have example on monopole and dipole calculation. See you on next video.